Hello and welcome to Organic Chemistry Review, and today's presentation is brought to you by Science Visualized. Today we're looking at Organic Chemistry Review, Part 3A. The first question says, write the number of signals or peaks expected on number 1, carbon-13 NMR spectrum, and then B, proton, that's H, proton NMR spectrum of the compound below. So if you look at this compound, you see that it has a plane of symmetry that divides that into two, and then you have another plane of symmetry here, and that basically means that this and this and this are all the same chemical environment. So that's one signal, and then the second signal will be here, and then the third signal on carbon-13 NMR will be this carbon here. And then the fourth signal is that corner. And the fifth signal is here. So for carbon, which is A, we have 5 absorptions or signal in the carbon-13 NMR. Now switching to proton NMR, we'll see that these carbon are in the same chemical environment. The hydrogens on them will also be in the same chemical environment. So that's one signal. And then the second one, so on that same carbon. And then number 3, same chemical environment, 3. But number 4 doesn't have any proton. And then number 5 has another hydrogen, has 2 hydrogens, so that will be number 4. And as a result, you have 4 absorptions or 4 signals in the proton NMR spectrum. Next question. It says that from the structure shown below here, calculate the multiplicities of the protons at positions labeled A and B. Anytime you are asked for multiplicity, you use the formula N plus 1 rule, where N is the number of hydrogens or protons on the neighboring carbon that's different from the carbon that you're looking at. So for example, if you're looking at this carbon A shown there, it has 1 hydrogen, so that one has 1 hydrogen. But the neighboring carbons, we have 1, 2, and 3 carbons. This carbon number 1 has 3 hydrogens, carbon number 2 has 3 hydrogens, and carbon number 3 has no hydrogen, so 0 hydrogen. To determine what the value of N is, you add all the protons or hydrogens on the neighboring carbon. So we have 3 plus 3 plus 0 gives you 6. So N equals to 6, and therefore that formula becomes 6 plus 1, which equals to 7. And therefore the multiplicity for A is 7. And that one is called septet. And you can use a Pascal triangle to determine the intensity of that multiplicity. Now let's look at B. The proton on that carbon labeled B, it has a neighbor here that has 2 hydrogens, a neighbor there that has 1 hydrogen, and a neighbor there that has 0 hydrogen. So when you add 2 plus 1, that gives you 3 plus 0 gives you 3. So N plus 1 equals to 3 plus 1, which equals to 4, and therefore the multiplicity there is 4, and that one is called quartet. The intensity of quartet is 1 to 3 to 3 to 1, and you get that from the Pascal triangle. So that means when you split that peak, the first one, the height will be 1, and then the next one will be 3, and then 3, and then 1. Thank you. If you enjoyed this presentation, please subscribe.